They absorb everything that crosses their event horizon and release nothing back. Entire stars, gas clouds, and even light vanish in their shadow. And yet there is something even more menacing. Scientists, equipped with the latest models and observations, have concluded that black holes are far from being the only cosmic predators. Some objects possess such destructive properties that black holes seem almost harmless in comparison. Imagine a star capable of annihilating all life within dozens of light years, or a cosmic structure capable of tearing apart space-time itself. Picture an object so dense that a teaspoon of its material weighs billions of tons. Neutron stars are among the most extreme objects in the universe, born from the fiery apocalypse of supernovae. When a massive star explodes, its core collapses under its own gravity, compressing millions of kilometers of scorching matter into a tiny sphere just 20 kilometers in diameter. If Earth were to suddenly transform into a neutron star, it would shrink to the size of a small city, and its surface would become a death trap. Gravity on a neutron star is 2 billion times stronger than Earth's. This means that if you somehow stood on its surface, which is impossible, you would be instantly torn apart. And if you tried to jump, you would fall back at a speed exceeding 50% of the speed of light. But perhaps the most terrifying thing is falling onto such a star. If a spaceship got too close, it would be stretched into an infinitely thin thread before ever reaching the surface. This phenomenon is called spaghettification, an effect where different parts of an object experience such vastly different gravitational forces that they are literally stretched to their limits. But even just flying near a neutron star could be fatal. Its gravity creates a field around it where atoms cease to exist in their familiar form. Yet there is a special class of these stars that are even more terrifying: magnetars. If an ordinary neutron star is a gravitational monster, then a magnetar is a long-range destroyer. It possesses a magnetic field a quadrillion times stronger than Earth's. Magnetars can unleash immense magnetic storms that destroy electronics, wipe hard drive data, and even disrupt molecular bonds. If such an object were just a few light years from Earth, it could annihilate all life, literally tearing apart DNA molecules. Scientists recorded one of these bursts in 2004 when a magnetar known as SGR 1806-20, located 50,000 light-years from Earth, emitted an energy pulse that temporarily ionized the upper layers of Earth's atmosphere. It was a kind of warning shot from the universe. Had it been closer, humanity might have simply ceased to exist. But even without magnetars, neutron stars are dangerous. Sometimes they merge with each other, and this event is accompanied by the most destructive phenomenon in the universe: a gamma-ray burst. This is an explosion of energy comparable to 1 billion trillion atomic bombs detonating simultaneously. If such a burst occurred within a few thousand light years of us and was directed toward Earth, it could vaporize the ozone layer, dooming all surface life to slow it. Black holes at least remain silent, while neutron stars attack. When people think of black holes, they often imagine absolute darkness, an enigmatic entity that simply consumes everything around it. But in some sense, black holes are actually safer. They don't emit deadly magnetic storms, they don't unleash gamma-ray bursts, and they don't stretch matter into kilometers of lethal radiation. They simply exist. Neutron stars, on the other hand, are active killers. They emit, tear apart, and destroy. If a black hole is the tombstone of matter, then a neutron star is an uncontrollable force of destruction capable of wiping civilizations off the face of the galaxy. Imagine a light source billions of times brighter than the sun, so bright that it can be seen from the other side of the universe. Quasars are among the most powerful and destructive objects known to humanity. A quasar is not just a glowing dot in the sky. It is the active nucleus of a galaxy, with a supermassive black hole at its center. But why does it shine so brightly? The answer lies in the colossal amount of matter falling into its bottomless maw. As gas, stars, and even entire planets get pulled into the quasar's gravitational domain, they accelerate to monstrous speeds, heating up to millions of degrees. This turns the vicinity of a black hole into a boiling inferno where matter literally evaporates, releasing enormous streams of energy. If our galaxy became a quasar, Earth would likely not survive. Even at the outer edge of the galactic disk, our planet could be exposed to intense radiation, which would vaporize the atmosphere and scorch the surface. But the most terrifying aspect of quasars is their relativistic jets. These narrow yet incredibly powerful plasma streams shoot out from the quasar's poles at speeds approaching the speed of light. They pierce through space, annihilating everything in their path. Scientists have observed cases where these jets pierce through neighboring galaxies, obliterating their star systems. Essentially, they are cosmic laser beams capable of erasing entire civilizations from existence if they happen to be in the way. Now imagine our galaxy being struck by the jet of an active quasar. It would be like an ultra-powerful flamethrower, vaporizing all life within seconds. And the scariest part? Such processes are actually happening in the universe. Black holes can consume stars, but they do so silently. Quasars, on the other hand, are destroyers. They scream into space with their blinding light, warning, "I destroy galaxies." If in the distant future, humanity searches for new worlds to inhabit, quasars will undoubtedly be at the top of the "do not approach" list. Bosons are a special class of particles, including the Higgs boson. If bosons capable of clumping into... If such a star existed in our galaxy, we might never detect it, at least not directly. It doesn't emit light, doesn't interact with normal matter, and remains completely invisible. However, its gravity could betray its presence. Imagine astronomers observing a strange phenomenon, stars suddenly altering their orbits, as if an invisible massive object were influencing them. They could calculate its mass, but wouldn't see it, even with the most powerful telescopes. This could be a sign of a boson star. Even more intriguingly, such stars could serve as an alternative to black holes. Whereas normal matter falling into a black hole disappears beyond the event horizon, in the case of a boson star, things could be different. Matter might pass through it or become trapped in its invisible gravitational prison forever. The most terrifying thought is that boson stars could exist right now, even within our galaxy. We simply have no way of detecting them. They could be lurking between star systems, hiding in the dark intergalactic voids, or even residing near Earth, completely unnoticed. One of the most intriguing clues comes from anomalies in gravitational lensing. Sometimes the light from distant stars is distorted, as if a massive object is blocking its path, yet no visible body is present. This could be anything: dark matter, exotic objects, or one of these unseen boson stars. Black holes terrify us with their insatiable hunger, but at least they make their presence known. Boson stars, however, simply exist, and perhaps we have been living among them all along without ever realizing it. Cosmic strings, fractures in reality. We usually think of space as something continuous, smooth, stretching infinitely into the depths of the universe. However, modern theories predict that this smoothness may not be as perfect as it seems. In reality, the so-called fabric of space may be riddled with gigantic cracks stretching for billions of light years. These fractures are known as cosmic strings, some of the most terrifying objects that, if they exist, could alter gravity, time, and the very structure of reality itself. Cosmic strings are not the kind of threads or fibers we are familiar with. They are incredibly dense, one-dimensional defects in space, formed in the first moments after the Big Bang. Imagine space as the frozen surface of a pond, and cosmic strings as deep cracks in the ice that appeared as it cooled. They are almost invisible but possess colossal mass. A single cosmic string can be billions of light years long while being thinner than an atom. Yet despite their minuscule width, their mass is so enormous that just 100 kilometers of a cosmic string could weigh more than the entire Earth. Physicists suggest that if such a string passed near us, it could gravitationally bend light in space, creating strange distortions in the starry sky. If a cosmic string were to pass through our solar system, it would be catastrophic. Its gravity could tear planets apart, alter the orbits of stars, and even distort the flow of time itself. Now imagine a cosmic string moving through space at nearly the speed of light. Everything that enters its zone of influence could be stretched, warped, or even erased from existence. A collision between Earth and such a string would lead to the planet's rapid annihilation. It would be shredded down to its atomic components in an instant. One of the most terrifying effects of cosmic strings is the gravitational waves they could produce. These strings might send powerful ripples through space-time, stretching and compressing reality around them. If we were near such waves, we could experience bizarre phenomena, time speeding up or slowing down, objects changing size, and light distorting so drastically that the world around us would appear utterly alien. Scientists have long been searching for evidence of cosmic strings. One way to detect them is by observing how they bend the light from distant galaxies. In some cases, astronomers have noticed strange effects, stars and quasars appearing duplicated in the sky as if reflected in a warped mirror. Some researchers believe this could be the result of a cosmic string passing in front of a light source. But there is an even more chilling hypothesis. Cosmic strings may exist right now, moving through the universe, but we simply cannot detect them. They are too thin, too fast, and too alien for our perception. Some have even suggested that if the chances of Earth encountering a cosmic string are incredibly low, but if it ever happens, nothing will save us. The gravitational rupture would destroy the planet in a fraction of a second, and the impact of such an event would be so immense that it could be detected from millions of light years away. However, there is also a more intriguing idea. If we could somehow control these strings, we might learn to use them for time travel or even for creating wormholes. Some physicists speculate that a cosmic string looped into a closed circuit could form corridors through space, leading to distant points in the universe. Thus, cosmic strings remain one of the most mysterious and terrifying objects we have yet to discover. They do not consume matter like black holes, they do not explode like supernova, and they do not incinerate galaxies like quasars. They simply exist, silent fractures in reality itself, ready to tear space-time and everything within it apart at any moment. Devouring voids, the places where reality disappears. Yes, we often think of black holes as the ultimate form of destruction, insatiable giants that consume matter without a trace. But what if something even stranger exists? Imagine an object that doesn't just absorb matter, but erases it from reality as if it had never existed. These are devouring voids, zones where not only matter disappears, but also any information about it. These anomalous objects are so contradictory to our logic that their existence sounds like pure science fiction. But only at first glance. The universe is vast and full of emptiness, but not all voids are the same. In ordinary intergalactic space, there are still traces of gas, dust, and wandering particles. However, astronomers have encountered a shocking anomaly, vast regions where seemingly nothing remains. One of the most famous examples is the Buddhist void, a giant area in space with almost no galaxies. For comparison, a typical region of the same size should contain thousands of galaxies, but here there are barely a few dozen. And this is not just a random lack of stars. It seems that matter has vanished from this region for reasons unknown to us. Physicists have proposed several hypotheses. Perhaps a gigantic black hole is responsible, but in that case, we would detect powerful X-ray emissions from falling matter. Another theory suggests a collapse of space-time itself, but this would contradict standard cosmological models. Or maybe something entirely new, an unknown mechanism that literally erases matter. If this hypothesis is correct, and there are regions where matter disappears without a trace, what could be causing it? One of the most disturbing theories involves quantum information. In normal black holes, matter crosses the event horizon, But in theory, information about it is not lost completely, at least according to the principle of information conservation in quantum mechanics. However, devouring voids violate this law. They do not just destroy particles. They erase all history of their existence. It's as if pages in a book disappeared, along with any memory that they were ever written. Scientists call this gravitational annihilation, a process in which space literally collapses in the absence of matter. This means that objects falling into such zones don't just get destroyed, they cease to exist in every conceivable way. So far, devouring voids have only been observed on cosmic scales, but if they can appear in galactic structures, there is nothing preventing them from emerging closer to us. Imagine that in the distant future, astronomers discover that certain stars are not simply fading or falling into black holes, but are outright vanishing from existence. No gravitational effects, no trace of energy, just an infinite emptiness where something once was. Some physicists seriously consider the possibility that the universe will not merely cool and stagnate in the distant future, but will be completely erased by such a phenomenon. Perhaps devouring voids represent the final stage of the universe's existence, when not a single particle, atom, or star remains. The universe is full of cosmic nightmares. Ultimately, when it comes to the most terrifying objects, black holes may seem like the clear frontrunners. But as we have seen, there are things far worse. Neutron stars, with their extreme density and deadly magnetic fields, can vaporize everything around them. Quasars turn galaxies into blazing wastelands, radiating energy greater than trillions of suns. Boson stars, hypothetical monsters that may exist under exotic physics, hide in darkness, unseen. Cosmic strings slice through space-time, creating gravitational catastrophes. And finally, devouring voids defy the very logic of the universe, destroying matter and information without a trace. The universe is full of horrors we have yet to understand, and who knows what other nightmares lurk in its infinite darkness.